One of the big challenges for deploying autonomous vehicles is that by all appearances, the real world has a heavy-tailed distribution of objects and events. Let's break down what that means and why that's such a big deal. Let's say that you're going to assume that you have random independent arrivals of weird things on the road, things that your sort of system hasn't yet trained on, hasn't encountered, triggering conditions that are going to break your system because you haven't trained on it, it's not part of your requirements, and so on. If you have an independent random arrival rate, things might not be too bad. You test and you get all the common things you see in testing, and you say, that's okay, the edge cases we did not see in testing are so rare, the area under the curve is so small, it's okay, we're acceptably safe. But here's the tough part. When you say that surprises arrive very rarely, that implies that you can retrain your system and handle all the area under the curve without testing all that much. But it isn't about how often surprises arrive. It's about the population of surprises that arrive. What if, even though surprises do not arrive often, every single time it's a different one? If you look at a different distribution, a power law distribution, often associated with the 80-20 rule, what you see is that for the same area under the curve, a lot of the population of the arrivals is shoved out towards the far end of testing time. That yellow space is the same area under the curve under the tail that was under the initial part of the curve for random independent arrival rates. So it's a heavy tail because there's a lot of the population way out at long testing times. If this is the case, trying to test on all the common things might not be enough because there's so many uncommon things you may not be able to prove safety using an iterated set of testing approach.